So in this video, we're going to build upon what we called the building blocks of geometry, the point, the line, the plane, and the space, and create some of the other fundamental objects that we interact with in geometry, namely segments and angles. And so just letting you know ahead of time, this video is a little bit of a definition dump. There's a lot of ideas that we're going to come across here, a lot of things that you may have seen before, some things that you may have never seen before, but this video is strictly definitions and talking about these foundational pieces, the segments and angles in geometry. So let's go ahead and get started. First, we're going to talk about segments as simple objects in geometry. We talked about a line, which is one of those foundational building blocks, but if we choose 2 points of the line and restrict our object to just the line space between them, then we get something called a line segment. That's all points between and including A and B are called the endpoints. Go ahead, pause the video, write these down, come back when you're ready to move on. It's also entirely possible that instead of just having a segment, we stop at either A or B and continue infinitely on in the other direction. Those are things called rays. Ray AB starts at A and travels through B infinitely. A is called the endpoint. Ray BA starts at B and travels through A infinitely. Point B is an endpoint. Here, again, it is incredibly important the order that we designate our rays. AB starts at A and goes through B, and we often give it a one-sided arrow on top of it. BA starts at B and goes infinitely through A. B is the endpoint. So the order of the points here is important. In a line segment, it's not. In a line, it's not. An array, it is. Go ahead, pause the video, copy these down, come back when you're ready to move on. If you have 2 rays that have the same endpoint and move in opposite directions so that together they create a line, then we call them opposite rays. If rays CA and CB are on the line AB, then CA and CB are opposite rays. Go ahead, pause the video, copy this down, come back when you're ready to move on. So now that we have the basic idea of lines, rays, and segments, there are a lot of things we can do, particularly with segments. Things that go on infinitely are not necessarily as interesting because they don't have any length that we can measure. So something that we know about segments is something we call the segment addition postulate. The formal definition is if C is between A and B, then the length AC plus the length CB is the length AB. We can put it on a ruler or on a line here like this, and we can see that very obviously, that the distance from A to C, or from A to B, rather, is the distance from A to C plus the distance from C to B. This should be incredibly intuitive to you. If we put 2 things together that have a length in and of themselves, then the resulting object has a length of the sum of the 2 other objects. This is something we call the segment addition postulate. We have one line segment added to another line segment, and if one line segment has length x and one line segment has length y, then the entire line segment has length x plus y. Incredibly intuitive. Go ahead, pause the video, copy the segment addition postulate down. Let me correct that spelling there, I'm noticing. There's an A there. And come back when you're ready to move on. So related to segment addition, we could entirely have 2 line segments that are the same length. 2 lines are always the same length because they're infinite. 2 rays are always the same length because they're infinite, but we don't call the lines or the rays congruent necessarily. But 2 line segments that have the same size and the same shape or the same length are called congruent. That is also the word that we use to refer to objects that have the same size and same shape. So here, AD, the segment, is congruent with this symbol to EB. It's an equal sign with a squiggle on top. Again, pause the video, copy these definitions down, come back when you are ready to move on. Again, we are now approaching halfway through this video here. It is a bit of a definition dump. The reason why we are doing it in the video and not just as some definitions on the Canvas page or just as a downloadable worksheet is so that we can have this commentary here in a way that takes some common misunderstandings and eliminates them from the start. It's not the most exciting video that we have, but it's an important series of definitions. So something that you may have seen before, in fact, almost certainly have seen before in algebra, is the idea of a midpoint. On a coordinate plane, it's the point that is midway between 2 points, and the same thing is true on a line segment. If A and C are the endpoints of a line segment, then there is a unique point B. That means there is only one, so that AB is equal to AC. And if you have a line that goes through that midpoint, then we call that line the bisector. Notice it can't be AC, otherwise it's just the line itself, but any line that travels through the midpoint of a segment is called a bisector. Go ahead, pause the video, copy this down, come back when you're ready to move on. All right, so that is the end of the data dump for segments and midpoints and segment bisectors. We have a little bit more to go through when it comes to angles. A lot of this will feel familiar, and we'll try to go through it as efficiently as we can. So first, the definition of an angle. An angle is formed by two rays with the same endpoint. All angles have interiors and exteriors. The interior of the angle is the area between the two rays where we're going to take its measurement, and the exterior of the angle is the area outside the two rays where we are not going to take its measurement. So go ahead, pause the video, copy these down. This diagram we're going to add some things to here in a second, but copy down the definition as well as the diagram and come back when you are ready to move on. So moving forward with angles, we have the rays that are both known as sides of the angle, and the common endpoint is known as a vertex. So on to that diagram that you had of those angles with point B on one ray, point A on one ray, and point O on one ray. The rays themselves are sides. The common endpoint is a vertex. Go ahead, pause the video, copy this down, come back when you're ready to move on. And the last thing that we're going to talk about in terms of the very basic definitions of angles, although we have a few more after that, is how to name an angle. When we have a line segment, we name it according to its endpoints. When we have a ray, we name it according to the endpoint, then any other point on the ray. When we have a line, we just name it according to 2 points on the line. But for an angle, we need 3 points. We need a point on a ray, or a point on each side, and the vertex. So when we name an angle, we name it either using a number, such as calling this angle 1, or we name it using 3 points. One on each side and one that's on the vertex. The middle letter of the angle must be the vertex because basically what we're going to do, and you'll see this in other things too, is start from, in the case of naming it angle BOA, start from B and walk around the angle in the direction of B to O to A. Similarly, if we're going to name it AOB, we can start at A on that ray, walk to O, and then back to B. So go ahead, pause the video. Write down the names of this angle and any other markings there that you need to remember how to do this. Definitely want to write down that the middle letter of the angle must always be the vertex. That's how angles are named. We have a few more definitions as it relates to angles, and then we will be ready to end the video. So it's entirely possible that two angles share a ray. If that's the case, we call them adjacent angles. That are angles in the same plane that have a common vertex and a common side, but no common interior points. So angles 1 and 2 are adjacent. Angles 3 and 4 are adjacent. Angles 5 and 6 are not adjacent because they don't share a ray. Angles 6 and 7 are not adjacent because they don't share an endpoint. Angles 5 and 8 are not adjacent because angle 5 shares an interior space with angle 8. But two adjacent angles here are angle 8 and angle 6 because they share a ray, but they don't have any common interior endpoints. Angle 8 being the marking here for the entire two-angle section here. When we have different marks that cover angles, we use them to represent that there are different angles there. So a single mark for angle 5, 2 red marks for angle 6, 3 red marks for angle 8. Go ahead, pause the video, copy down the definition and the diagram of adjacent angles. Come back when you're ready to move on. So when we measure angles using units called degrees, and we measure them using a protractor. An angle that's formed by a straight line is we call having 180 degrees, and angles that intersect what we call perpendicularly, we call having 90 degrees. So there are lots of different ways that we name angles. A lot of these you have probably heard before. An acute angle is between 0 and 90 degrees, a right angle is exactly 90 degrees, an obtuse angle is between 90 and 180 degrees, and a straight angle is exactly 180 degrees. These are definitions of angles that you have probably heard at some point in your mathematical background coming up to this point. There is one other additional type of angle. It is possible for an angle to represent a rotation greater than 180 degrees, in which case we call that a reflex angle. So if you need to, and this will be the optional points here, you can go ahead and pause the video and copy down these definitions, anyone that you don't know, or you can just keep listening and move on. So specifically for a reflex angle, let's draw a diagram of that to make sure that you've got it. If this green line represents straight, and then we could have an angle there, in most cases we would talk about the obtuse angle that is related on that side. But the other angle on the other side, more than a half rotation, this is the reflex angle. All right, 2 more slides, and then we're done. The angle addition postulate, the same as the segment addition postulate. If angle D lies in the interior of angle AB, or if point D lies in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC is the measure of angle ABC. Basically, if we have adjacent angles, we can add their measurements together to create the larger angle that they create. Go ahead, pause the video, copy this down, and then one more slide. So here we have, if we have angle 1 and angle 2, then the total measurement of angle ABC is measure of angle 1, that's what the little m is, plus measure of angle 2, again, in both cases. If they are formed from a straight line, then the sum of angle 1 and angle 2 is 180 degrees. Finally, last definitions involving angles. Congruent angles have the same measure, and if there's a ray that divides an angle into 2 congruent halves, we call it an angle bisector. I'm just going to wrap up the video here. I know and I understand that is a lot of definitions. As I said, there were a few different common misconceptions that I wanted to make sure to point out to all of you all at once, or at least asynchronously as you're all watching the video, which is why this was a video and not just a list of definitions. So congruent angles have the same measure. Angle bisector is a ray that divides an angle into 2 congruent angles. Go ahead, pause the video, write these down. Pause the video before the video ends or you may lose the screen. And then you can move on to the next activities.